Session. Thank you for staying up until the last session of this conference. I'll be talking about CueSheet, which is a framework to rethink the Spark Submit and SPT assembly. Let me start with a little bit about me. My name is Jong Wook. I'm studying music technology at NYU as a doctoral student. And previously, I was software engineers in those two Korean companies, Kakao and NCSoft. I worked as a recommendation systems developer at Kakao and online game server developer at NCSoft. And this talk actually is going to be about what I built at Kakao. And Kakao is like a big Korean internet company that is like Uber, Facebook, Amazon, Google, Spotify, Pandora. At the same time, it has a bunch of services. And because of this just so variety of this kind of services, it is really fun to work in a recommendation system for those services. These are two of the recommendation-related services that I worked in Kakao. First one is Apache S2 Graph. It is a graph database for OLTP kind of traffic. And the second one is closed source spot Rubix. It is a real-time news recommendation system, and both of them heavily utilizes Spark as any others does. And this is the background that I start the presentation. It is about an inconvenience that we have while building those kind of complex Spark applications. Let me start with notebooks. Notebooks are great in many cases. We saw Databricks and Zeppelin and many other notebook kernels in this conference as well. And it's very good for exploratory analysis and visualizations or dashboard. And it's usually suitable for interactive interfaces, usually in web browsers. But for more complex business logic, wherever the number of lines of code are exceeding like 20 lines, browsers are not just enough to implement that when we have like a lot of dependencies and just logic is too complex. So what we do in that case is to resort to a regular Scala project. So in that familiar Maven style source tree, and we developed in local files. So by doing this, it is easier than in browser to do dependency management and tooling like version control and collaboration. And most importantly, we can get help from IDE, and it's tremendous. But if we develop Spark applications based on that source tree, the documentation says us to do Spark Submit, which assumes we do import Spark as a provided dependency and create an Uber jar using SPT assembly and specify configurations in the shell command as an argument to Spark Submit script. So we need to make a shell script launching Spark Submit. And assembling is very tricky, and because of that reason, Spark 2.0 stopped building assembly. And just the sole notion of shell scripts are awful, especially as a previous game server engineer who mainly developed C++ and Java. And when I joined Kakao 3 years ago, they were using Hive exclusively, and their pipeline is Jenkins calling a master shell script, and that script calls a task-specific shell script, and then that script calls a Python script to convert the template HiveQL to a specific HiveQL, and that HiveQL runs another Python script for UDF. And this is cascade of unverified programming languages are making just wanting to flip the table. And if we do Spark Submit with shell scripts, we are just basically trapped in this vicious cycle of IDE and shell scripts and browsers. So it's just dispersing our attention, as you see right now, and it makes it hard to concentrate. So this is the motivation that made me to develop CueSheet, this framework, and one of the goal is to escape from the shell script. At the surface, CueSheet is an abstract base class that you can use with Scala language. You can program as if you are in the Spark shell in the body of an object extending CueSheet. So you can access SC, Spark context, and Spark streaming context, Hive context, and Spark sessions as if it is in the Spark shell in that object body. And CueSheet, the upper class, will take care of creating them as needed. And this object becomes a JVM main class so that you can right-click on that and click Run to just launch the Spark applications. And you see that SC is just provided here, so you might be wondering, how do we configure that? So the configuration is given in a separate file that is in typeset config format or hawcon format. It is usually stored as a class path results, usually in application.conf, but you can specify other names as well. And it stores the Spark usual configurations as well as the configurations for Yarn clusters, their sizes, memories, number of instances, and the XML files to download and create the Hadoop configuration. And you can see that this framework makes separation of concerns, which is a value of a software engineer, at the configuration for running the application, and then business logic itself in the Scala file, and then deployment and execution is covered by separate components of the system. So the separation of concerns is done here. And most importantly, remember that we don't need to fiddle with the shell scripts anymore. And as I said, you can launch the app directly from the IDE and don't need to call Spark Submit or shell scripts anymore. And because we don't need the shell script, it supports Windows automatically without worrying about batch files or even PowerShell. I don't want to talk about that. Anyway, and you can also debug like any other JVM applications, setting breakpoints or using any other features from the IDE. One of the things that CueSheet application does is to analyze the dependencies. And it analyzes the dependencies between all jars that are present in class paths and constructs a directed acyclic graph like this. And it figures out what jars are dependencies of Spark. So these are those jars, and these jars are automatically installed to HDFS in advance. So when you run the CueSheet application, only those portions are uploaded to the cluster. So it's very fast, and it's like running SPT assembly with provided dependencies, but without going back and forth between terminals. And those red circles are usually like hundreds of megabytes, so that's our trickier part. But the blue circle is usually very small, and it's very quick to launch. And one more thing that CueSheet provides is a one-liner script for deployment. So once debugging is complete, it's time to deploy the app, and CueSheet will provide you a long line of shell command you can paste into tools like Jenkins or Marathon. In that way, you don't need to save or version control any shell scripts, and because it is generated by a program, you don't need to error check for that. So let me go directly through a live demo of CueSheet. You can Google CueSheet starter kit and clone this demo for trying yourself. This is very simple CueSheet application that is similar to SparkPy example. It samples random points inside the unit square and then calculates the proportion of the points that are inside the unit circle to get the number of approximate value of pi by multiplying that by 4. And running this application is as simple as right-clicking and run inside the IDE. And it is nothing surprising. It's running on locally now. So you can see that the approximate value of pi is obtained here, 3.14. And another thing that you can do is to specify the master URL instead of local, but yarn colon and then the download link that contains a zip file that contains the XML files for Hadoop configuration. Alternatively, you can specify the class path that has the XML files in the resources directory, but this time we'll use this. I have a Cloudera Quick Start VM running right here at the laptop. So let's see. And before launching it, let me set 2 breakpoints here and run. So it is downloading the configurations and assembling the 80 kilobytes of the application-specific jars, and it's now connecting to the Hadoop clusters, and it is being accepted at Yarn. So it's accepted, it's running, and yeah, it's called in the breakpoint. In this breakpoint, you can check the values, and you can also skip through it, and then resume the execution, and the number of approximate value of pi is calculated in a distributed way, and you can also check the value of this string, or let me see, and it will print to the console the value you seen. So it is without any change of the source code, you can launch the application to Yarn cluster directly, and again, without using shell script as well. And anyway, this is the one-liner script that I talked about, and you can copy this and paste it in a Chronos or Marathon, then this job is already production ready. Let me launch another example. It is a streaming app, because this uses streaming context instead of Spark context. If I click here and run, it is doing the same thing, compressing the application and connecting to the Yarn, and it is accepted. And it's running here. So we can see the streaming UI by connecting to Yarn. It's maybe Spark context is initializing, so it's why it's slow. Anyway, you know, live demos. Anyway, it's anyway calculating the value of pi. You see that we are currently using 1 million samples per second, so it's going closer and closer to the real values of pi, 3.14159 something. So let's keep this way and resume our presentation. Because this CueSheet is started as a collection of reusable functions that we use while developing Spark applications at Kakao, it happens to have a number of additional features, mainly around RDD, because it was like 2 years ago. It has source and sync to a number of NoSQL databases, including HBase, Elasticsearch, and Couchbase. And it supports client-side throttling to prevent overwhelming those servers. And it is powered by Mango. It is another Scala library. You can check that out at that URL. It is a Scala core utility library providing a minimalistic Scala API focusing on the asynchronous programming, like JSON, logging, concurrency, and client interfaces to HTTP and Telnet, OpenTSDB. And it is being used in both data analytics and data serving layer at Kakao, like web servers as well. And a number of data analytics algorithms like nearest neighbor collaborative filtering and alternative join algorithms. And it also happens to feature a kill switch, because it is sometimes tricky to let me restart this application. And I have no idea. I have tried like 10 times here, and it's always the demo that it fails. Anyway, what I was trying to show you is this. No, it's fine. So what I was trying to show you is it adds a stop tab in the Spark UI so that you can stop your Spark streaming application in an increasing degree of seriousness. You can stop the Spark context, or you can stop the Spark context and streaming context with stop gracefully setting set as false. And also you can kill the Spark driver abruptly. And we found this very useful. Although it is a little bit obtrusive, but sometimes you get lost control of your Spark streaming application, and being able to kill right on the UI is a nice quirk to have. Let me continue. So there are a number of future works that are planned to CueSheet. So it will be relatively easy to support upcoming Spark version. It currently supports Spark 2.1, and it supported Mesos and Spark standalone servers back in the in-house version when the Spark is 1.x, but while open sourcing it and converting it to support Spark 2, the support was postponed. So it will be helpful, and I want to make it work with Spark standalone and Mesos servers. And also a lot of feature requests from our colleagues are supporting Kerberos authorization. And because we are using a number of tricks of Scala 2.12, number of tricks of Scala and JVM, supporting Scala 2.12 and Java 9 will be a little bit of tricky problem. So let me summarize. Using CueSheet, you can develop Spark applications without shell scripts at all, no Spark submit and no SPT assembly. And this made me, as a developer, quite happy developing those Spark applications, because I don't need to fiddle with the terminal and shell scripts that's very error prone, as I said. And as you see, we can just fill inside the object body, so it's very minimalistic API for building Spark applications in Scala. And the separation of concern, the configuration and business logic, and also the execution is covered in separate components, and being able to launch from the IDE, and also a small payload generated using dependency analysis, and the one-liner for deploying the application in either Marathon, Kronos, or Aurora, or Jenkins, and a few more handy features I just saw. Thank you so much. And this is the GitHub link that you can check out the CueSheet project that you can build Spark framework, and the Mango is a Scala core utility library, and this is a CueSheet Scala, the CueSheet starter kit. This is the project that I used during the demo, albeit it didn't go very well. I'm not sure how it went, but yeah, thank you very much for listening. This is my presentation. Yes. Well, so if you develop, so the Windows, it was about if you develop a Spark application using Spark Summit, it is either a shell script or a batch file, as Spark distribution provides, and you will need to maintain either one of that. And if your workers are all using Mac or Linux, it's fine with shell scripts, but usually there are people using Windows laptops, and we will need to call spark submit.bat or cmd. And in that way, we have to maintain two separate files, and that's very cumbersome. Plus, it's not compiled or verified anyway. So using this, every submitting operations are done in JVM, and JVM is automatically platform independent, so we don't have to worry about Windows-specific treatment. All right.
Great. Do we have any other questions? All right.
Hi. Can you put breakpoint into the mapper inside the IDE?
It's only possible in local mode.
Okay. Anyone else? All right. So let's give a round of applause to our speaker, Jong Wook. Thank you. Thanks.